In this video, I'm going to go over examples of greatest common factor, or GCF. So for number 1, we're given 5x squared minus 15x minus 10. So you want to think of the largest number and the largest amount of variables you could take out of all 3 of those terms. So 5, negative 15, and negative 10 all divide evenly by 5. And then you think, can I take out an x? Because these two have an x. But then the negative 10 does not have an x, so you can't take that out. And so after you take out the 5, you want to write what's left over. So if I take out 5, x squared would be left over from the first term, because if I multiply those together again, it would give me back what I started with. Negative 15x divided by 5 would leave me with negative 3x. So again, if I multiply those back together again, it would give me the middle term. And then 5 times negative 2 would have given me back the negative 10 I started with. So our final GCF factored form is we took out a 5 and we have x squared minus 3x minus 2 left over. Since we're only looking at taking out a greatest common factor right now, we would just stop there and not factor it any further yet. Let's look at example 2. We're given 4x to the 5th plus 16x cubed. So think of things like, what would multiply to give you 4? So you have 1 times 4 and 2 times 2. And then think of things that give you 16. So we have 1 times 16, 2 times 8, 4 times 4. And then 4x to the 5th contains 5 x's. And 16x cubed contains 3 x's. So you want to see what is the largest factor they have in common. And this time they do have x in both terms, so we'll be able to take that out. So if you look at all the numbers listed, 4 is the largest number they have in common. And then 16x cubed had 3 x's, and so does 4x to the 5th. So we could take out the 3 x's. So I'm going to put that in the same color I circled them so it stands out nicely. So 4x cubed they both have in common. And then what would be left over is the number that was right beside the 4, which is just a 1, and then the 2 x's, so we'll just say x squared. And then right beside the 4 over here was a 4, and it needs to be a positive 4, and then no x's were left over. So then check and see if this makes sense. 4x cubed times x squared does give us back 4x to the 5th for that first term, and then 4x cubed times 4 would give us back the 16x cubed that was our second term. So this is the correct factored form. Always keep in mind that factoring is the opposite of multiplying. So you should be able to check that you have the right factors if you're able to multiply them back together again to get what you started with. All right, let's look at one more example. So number 3, we have 6x cubed y squared plus 8x squared y minus 4xy cubed. So you think about 6 has 1 times 6 and 2 times 3 are its factors. 8 is 1 times 8, 2 times 4, and then 4 is 1 times 4 and 2 times 2. So then you're able to see all the numbers that are possible out of each of those numbers, and you can pick out that 2 would be the largest number they all 3 have in common, because your greatest common factor has to come out of everything in your polynomial. So I'm going to put a 2 out front for now. And then let's keep writing what else is there. So we have 3 x's in the first term, 2 x's in the second term, and 1 x in the third term. So that means that in common, each of them has at least 1 x that we could take out, but that last term doesn't have any more than that, so you won't be able to take more out. And then we look at the y's. The first term has 2, the middle term has 1, and the third term has 3. So we're able to take out 1 y from each term. I'm going to circle the first one just to keep it consistent. So let's take that out, and then we see what's left over. So what needs to be left over is what's left right beside those blue circles. So we have 2 x's and a y. So let's write that all back together again as 3x squared y. We have a 4 and an x left over in the middle. So positive 4x. And then we have 2 and then y. We have 2 y's left over. And the original sign was negative, so we need a negative 2y squared left over. Now, let's check and make sure this would make good sense. So if we multiply these back together again, would it give us what we started with is what we need to check for. All right, so 2xy times 3x squared y should give you 6x cubed y squared. Looks good. And then 2xy times 4x should give us back 8x squared y in the middle up at the top. So 8x squared y looks good. And then the last term would be 2xy times negative 2y squared. And that should give us back the negative 4xy cubed. So looks good. All right, so that's it for GCF.